Welcome to the demonstration of Horti+, the horticultural luminary data management and lighting design module for the horticultural world. Let's start with the demonstration showing how it is possible to manage the luminary data of an horticultural luminary. So we start from data coming from our laboratory. This is a GF file. It means that it is a file taken from our goniphotometers. For example, the measurements that we can perform over here at Oxitec. We simply drag and drop, and this is the information. So it is simply the photometry of the luminary. In this case, having the luminary being measured at the gonio, we have to first fix the matrix. As you can see here at 0, we should have exactly the same values. It is not possible. Whenever you run a measurement, it is always different. There are little differences if the measurement is performed correctly. So the first step is to normalize so that now you can see that we have exactly the same value. And then we have to check the efficiency. It should be 100%. In this case, it is 100%, but it may happen that there are other decimals, not the first two, but the third and fourth. So it is always suggestible that you perform 100%, the 100% feature, in order to perfectly fix the efficiency at 100%. At this stage, so we have the photometry, and we can add the spectrum. So the spectrum can come from a goniospectrometry, like in this case. This is a measurement performed in a second step after the photometric measurement at our lab. So we simply drag and drop. The program automatically recognizes the standard, recognizes the file, and then it asks you to select the standard you want to apply. So, for example, we apply the European standard. The program shows now the different spectrum taken, and it is possible to analyze one by one. Once you have finished, you simply press on OK, and the spectrum will be imported. This spectrum was taken in a range of 380 up to 780 nanometers. So it means that it is in the visible part of the spectrum. But if we want to switch to the horticultural world, we should select from here, from the field drop-down window, we should select horticultural. At this stage, you can see that the proper diagrams will be displayed, and it is shown down here with all the parameters related to the horticultural world. So in this case, we have automatically the program setting the spectrum analysis in between 400 up to 700 nanometers. But as you can see, we can change. We can fix the range we want. So we go back to horticultural. Down here, we may show the McGree diagram. We may show the yield PFD. And down here, the parameters for the flux, the luminous flux, the radiant flux in watt, the power in watt, and the efficiency as the ratio in between the ppf on the power. The ppf is the photosynthetical photon flux, and it is the flux in the horticultural world. And down here, we also show the other parameter, which is quite used in the horticultural world, which is the YPPF, the yield photosynthetical photon flux in micromoles. Down here, we have the ratio, and we have the ratio in between the red component and the blue component. At this stage, in order to complete the measurement, we can go back to the information and we can fulfill the information related to the luminary. So, for example, we can exactly define the code of the luminary, the name, define the family, while the measurements will stay the same because this is the photometric measurements. It is also possible, in case to add the list of instruments, you just input one by one. It is also then possible to save the table, because if the list of tools used at the laboratory stays the same for a long time, so it is the case simply to upload the table and whenever you need it. So in this case, you have to select from here. And from here, we may select for example, this one. But if you want to add another tool, you simply select the Add tool. So we confirm. And from here, we may also select power. If you want to input, for example, the flux and power curves in function of the driving currents, you can also have the standard list. So, for example, you may wish to add the list of the standards that have been used for the photometry and the uncertainties. It is also possible, for example, to add the image of the luminary, because it is very useful whenever you have a photometry to also see what was the luminary that was used for the measurement. And besides that, it is also very interesting to have the option like we have with PhotoView to add some other images which may be useful in future. So, for example, if you simply have the luminary image, that's it. But, for example, if you may add another image for the driver used by the luminary, or the lenses used same by the luminary, it is very useful whenever you have, after a while, after a few months, you want to go back and check what was the driver, to have all the information packed at the same location. The same for the reference image. For example, if you may wish to have an image detailing the planes, the C gamma system, measuring system, linked to the luminary. Why? You may also wish to have some images over here that then may be used for the printouts. if you want to print a report, including also the images of the instrument. So in this case, we can have a full package of information available through a single file. We are going to show you how we can save them together with the OXL file in a while. As you can see here, the polar diagram is fulfilled with the same color taken from the coordinates. So with photo view, it is possible to use exactly the color coordinates to fulfill the different diagrams. So we may have the polar diagram, we may have the Cartesian diagram, and so on. Also the 3D, it is possible to be fulfilled with the same, exactly the color coming from the luminary. At this stage, once we have finished inputting and defining all the information, we can save into a file. It is clear that it is not possible to save as an LDT file. Why? Because the LDT is a file introduced back on 1990, and it is extremely limited. It is only limited to photometry. We have no chance to save a spectrum. The same with the IS. This one is the IS LM63. It is a file similar to the ULM.1, and it doesn't allow to store the information related to the spectrum. So we have to move to more powerful files like the OXL that we introduced many years ago. We started to develop the OXL file back on 2007, so it means many years ago. And the OXL file is an XML-based file where you can store all the information, the images, the spectrum, the photometry, the list of instruments all together. But there are also some other files which were introduced some years ago. The UNI 11733, it is also an XML-based file, and this file is including photometry and spectrum, but it doesn't allow to include the images of the luminary or other images. It doesn't allow to include a complete list of tools, of instruments used at the laboratory. It doesn't allow to include uncertainties and so on. And the brother file, it is the ISTM33, introduced on November 2018. The UNI 11733 was introduced on January 2019. So these two files are coming from the cooperation in between the IS, the American IS, and UNI, the standardization body of Italy. And they are based on the same structure. It is exactly the same file for the 5 first parts. So there are a set of 5 data groups, and they are absolutely the same. Only the 6th part is different because when the file was under development, it was decided to leave the 6th section for the different countries in case they want to include some peculiar standards of their own. So, for example, in Italy, we introduced at this file, we introduced the capability to manage all data coming from the law we have over here for public lighting. So, if we go back on here, we can then save to the OXL file. Let's save the file into here. So we simply copy and we may say that this is our file. And we confirm. So In this case, we saved the complete set of spectra that were coming from the Gaussian spectrometry at our lab. So if we remove this one and we open again the file, we simply drag and drop the OXL file, you will have the full package of information available, simply with the drag and drop. If we save, let's repeat, if we save into, for example, the IS TM33 at the same folder, we have to also select if it is a relative photometry or an absolute photometry. Let's save as an absolute photometry. We remove, and whenever we drag and drop again the XML file, the IS XML file, you can see that we have the spectra all together, but we don't have the images. We don't have the other set of information like the instruments, like the standards, like the uncertainties at the same file. Let's say that in case it's clear that I showed you how to perform a Gaussian spectrometry through our machines, through our Gaussian photometers, like we can do over here at our lab. But it is then possible to save the information about the spectrum in a different way. Yes, it is. So, for example, if you have any tool, any spectrometer coming from any firm, you can, in most of the cases, save the file into an Excel file, into a CSV file, where you have the wavelength on one side, and on the other side, you have the radiant power. So this file, it is a very simple one, and maybe it may be taken from a sphere, and in this case, you can simply drag and drop in the same way like we did when we imported the Gaussian spectrometry in our format. So let's remove the spectrum. So now it is empty. Let's go back to the folder. We have over here the CSV file, and we simply drag and drop. And from here, we select the total radiant spectral power. So for example, this is the one coming from the measurement using a sphere, an integrating sphere. So we select the European standard, and that's it. But in place of having now the different spectra, we simply have a single spectrum corresponding to the total radiant power. And again, we save as a no Excel file, but in this case, single spectrum. That's it. Let's come now to the lighting design. So how we can use Horti+ to perform a lighting design for the horticultural field. So we simply open LightCalc, and over here we have to, for example, we start importing the DXF file of the ambient, of the area, of the interior where we want to install our horticultural lighting system. So here we have the DXF file. We have to check in between the DXF units and the meters over here, because the DXF file is not carrying the unit. It is brought simply in DXF units, but our program works in meters. It applies the international system, and so we have to find a way to convert the units into meters. So in this case, we have 26 units, DXF units. Is this corresponding correctly to 26 meters on X? We may say yes. Otherwise, we may switch from one unit to the other in order to find the proper one. Once you have finished also defining the offset, it means where you want to place the origin of the axis, for example, down to the left, you simply have to press OK. And at this stage, this window will appear where you may, in this case, we only have two layers, but in many cases, you have a huge set of layers, and you may wish to import and to consider only the ones related to the lighting and not all the others. So you may simply double click and you turn it off. Okay, let's stay in this case with the complete set. Now, this is our area, and from here, let's say that we want to define the project. So this is an interior. We start from here. If we press X on the keyboard, we may exactly get the point of the DXF, snap at the point of the DXF file. So it is much easier to draw the different lines. If you remove them, if you do not press anymore the X on the keyboard, then you can see that it is difficult to find exactly the point. So we press again, and once we have finished, we press Enter. Now we select, for example, this color, and we confirm. So this is our interior, and right now we simply have to select over here the photometry that we have created. So we place it here, for example, at the center. We may also visualize different views. So for example, in this case, we have the top view. We place it here. And we want to create a line of luminaires, so vertically. In this case, you just have to press the O at the keyboard, and as you can see, the line will be drawn vertically or horizontally. I press the left button of the mouse, and from here I can input the total number of luminaires, and once I've finished, I simply press OK, and the program will automatically multiply the luminaires and display all the luminaires in the interior environment. So over here, we can visualize the photometry. Okay, the photometry, and at this stage we can run the calculation. with a simple, once we're finished with the calculation, with a simple double click on the working plane, for example, but it is also possible to open all the surfaces related to the room, to the interior, and we can select the floor. And over here, we straight away have the values, but as you can see over here, we have values into luxes. So this is a calculation in the visual world. It is not an horticultural calculation. Why? Because I didn't remember to switch from the visual one to the horticultural calculation. So we have to go back, start again the calculation, and that's it. Right now, as you can see, we have horizontal PPFD, photosynthetical photon flux density, which is the corresponding luminance in the horticultural world, in the proper unit. So again, if we select the ambient floor, these values now will be exactly power values in power units. So you don't have to switch from, with our program, you don't have to switch from the visual, convert to the power world with external calculations. It is all done directly by the program. Over here, you can switch to the false color diagram, to isolines, and that's it. Over here, I could see this one seems to be turned off. Okay. Okay. Now it is correct. The dimmer was down to 12%. So from here, we have the false color diagram. We have the isolines. And about the isolines, we can show you that it is possible to switch into different systems. So for example, the auto palette or the auto gradient. In this case, for example, you may select exactly a color of your own and define exactly the palette in function of your needs. So for example, if you want to visualize this one, the 500 into a different way, you just have to select this color, and for example, you may add the blue, so that whenever you confirm, you will have the blue line, which is down here, and it is clearly defined among the other curves. From here, okay, we can go back, and for example, now we may add some furniture. So, for example, we may add a shelter, and this shelter may be scaled. This is, for example, the shelter used in agriculture, where you have all the different plants. And for example, we can also scale in this way. And right now, we may place it back at the wall. As you can see over here, we have this luminaire which is disturbing, so we may delete it. We run again the calculation, considering also the furniture. And if we go back, we can see that the calculation, oh yes, this one was placed in the, not in the proper way. So we go back, we select the luminaires, all the luminaires together, we move them, and we run again the calculation. As you can see, the calculation was performed directly in a spectral way. So it means that we take into consideration at our calculation the spectrum of the light, of the integrating spectrum. So it means that we don't have to run different calculations because it is spectrally done. And so you can directly visualize the results. Why? Because we straight away use the spectrum coming from the goniospectrometry or from the spectrometry. If you measure, in case only one spectrum in a single direction. Be careful in this case, because in case you don't use a sphere and you measure a single spectrum in a certain direction, usually C0, gamma 0, you may have variations. It means that one thing is the spectrum taken at the sphere. Another thing if you measure a single spectrum, because in this case we are saying to the program, listen, this is the spectrum corresponding to all the points of the luminaire. But this is not exactly what is happening in reality. The proper measurement is a goniospectrometry, where you take different and many spectra during the measurement. So you have a spectrum into different, in all the directions. Something less precise is the spectrum taken at the sphere. Why? Because it is an integrated spectrum, and we are giving the same information, so the same spectrum per any direction. It's much less precise, and it may bring to many errors if you take a single spectrum. Why? Because after that you may attribute the same spectrum to all the different directions, and this is not what is happening in reality. So best solution is a goniospectrometry. At this stage, once we have finished, we may select the surfaces of interest. Like in this case, we select the working plane, we convert them into isolines and into false color, and again this one into isolines and false colors. And if we open the photometry, we have the image, and the same image will be brought at the printouts. So if we select the project, the printer for the printouts, we may come to this stage where we have the full list of available pages, printout pages. We select print preview, and we have the luminaire image plus the photometry. So with all data. Oh, let's go back and select English. and let's select Bring Preview. So the summary, the project data and results, the source information, energy calculation, the luminary data, the aiming summary table. It is not necessary in this case, so we may delete it. Here we have the values, the horizontal ppf density values for the ambient, for the working plane. Then we have the isolux curves, we have the force color diagram, we have again, the iso-ppf, not isolux, but iso-ppf curves on the working plane, and the force color for the horizontal ppf. And that's it. So we may close. So as you can see, we can manage the horticulture lighting in a very, very simple way, both on the data creation and on the calculation. So you exactly manage the project in the same, exactly in the same way like you have been managing your lighting design from the visual point of view. Okay, that's it.